Then I will show you the reminder that you have 10 minutes to the end of the presentation.
Right.
Amazing.
I usually make talks are kind of shorter.
Yeah.
It's like the clock there.
Sometimes you have to go outside and you didn't realize about wait. I think we can start, so let me introduce Frank. And I know everyone is looking forward to find something new about the monitoring.
We'll try. Good morning, everyone. Thank you for making time Sunday morning. I know it's early. Everyone awake already? It's an entertaining talk just before, so that was good. So I'll be talking about the issue of monitoring. I have a particular take on it, which might be interesting, but I'll be covering general topics first, and then go on to two particular technologies that my group works on that have an unusual angle on this. So the first part might be familiar and boring. If so, just make some yawning sounds and I will move on. If it's interesting, then just ask questions anytime, and we'll get this done. So everyone has heard a monitoring word, right? Everyone knows monitoring is a good thing. But I sometimes like to think about it, step back a moment and say, why does monitoring exist? Why do we even need such a thing? So if you think about it, all monitoring is a way for a way for a robot to do your job, in the sense that once you have written the program, once it's running somewhere, you want to make sure it keeps running happily. And if something breaks, and it inevitably does, you want to be told that something is broken. So at the basis, the most basic level, it is there to warn you of something that goes wrong, so that you don't have to spend your own attention fixing it or noticing that something has gone wrong. And I'm sure everyone is here as a programmer. Everyone has seen hundreds of failure modes. There are all kinds, not just bugs in your program, but hardware failures, network failures, security breaks in where you have to take action, a huge gamut of problems, obviously. And there are too many problems to manually check. So again, we must delegate it to some kind of machine to do that. In some cases, the failures are very soft failures, in the sense that it's not that something is broken, it's that someone would like the software to sell more product. You know, it's a website that wants to sell 3,000 widgets a day instead of 2,000, and they're tweaking web server settings and so on, and they want to find out whether that has been successful or not. So sometimes it's that soft, the kind of failure that we want to monitor. So how does one find out that something has gone wrong? Well, there's some schools of thought where you basically just wait for reports to flow in. You kind of fire off a software package, launch it, deploy it either with a A/B type deployment, but you basically wait for someone to tell you that something is wrong, and otherwise just keep on and build. But normally, what is the most responsible thing to do is to let a computer program monitor all the other computer programs around and tell you when something is wrong. Again, all this is very basic, but it gets interesting in a second. Who can name more than 5 monitoring systems off the top of their heads? I'm sure you've seen. I have only 7 or 8 there, but with a little more effort, one can come up with 20 or 30. It looks like every year someone builds a new one that does something very similar to all the others. It's a very fertile ground for reinvention. And sometimes just choosing one is itself a big difficulty because there's, again, so many. And also because people come in with different biases, different traditions, and they're familiar with some and not others. Or their platform of infrastructure of choice might have 1 or 2 installed, and then you make it fit to whatever you need. So people tend to be very much creatures of habit, and they go with what is easiest, and they hate to choose from 30 options because it's a lot of work choosing, so they try not to. It tends to mean that it tends to make the reinvention problem a little bit worse because anything that's new and flashy naturally attracts attention, and then kind of fight. Well, I just get frustrated thinking about it because it's just funny how many new projects come up, advertise themselves, show up as the greatest new thing that will do everything except a few things, and then suddenly your decision matrix has become much more complicated, and you have to decide whether you go with the fashions or not. But the general patterns are all the same. You want to identify what it is that you want to measure, whether it's basic system statistics or something more complicated. You need to find a way of pulling the data in from its sources. You need to store it somewhere for long term. You need to draw it usually. Some people really are, well, our visual system is very tuned to finding patterns in graphs, of course. So people are used to visual renderings, visual drawings of the data to make good sense of it all. Other people don't mind grids of data, and computers, of course, they don't mind raw numbers at all. But sooner or later, at some point, one has to visualize everything just for the humans. And if something goes wrong, obviously, you want to be notified. So these basic 5 elements are essentially in every single monitoring system out there, and that's they change in taste and flavor and focus and emphasis, but the same elements are there. The interesting aspect of it to me, and which is what motivates this talk, is not the common elements, though. The common situations are already addressed in most of these tools. The interesting aspects to me are what do you do if something very unusual happens? What do you do if you go, sort of what Dan Walsh was talking about in the container talk a moment ago. If a failure occurs that is not already well handled by the monitoring statistics that you've collected, what else can you do? How are you stuck with what the system gives you, or can you go beyond it? I like to go beyond, and I like to explore how to go beyond for those unusual cases where you must, where the mystery is just too harsh. So why might we need something more than the normal monitoring systems data? Well, first of all, if you think about everything that goes on in a large system, there's simply too much in terms of number of different types of data that you might want to collect. There can be thousands, tens of thousands of different measurements you could take, and if you take them all, then you'll bog the system down while extracting it, and you'll bog down your network and your storage just transporting a thing. So you literally cannot collect everything you might want. And you also can't pull it frequently enough to get very high resolution data, because again, it has a multiplicative effect on resource requirements. So some systems try really hard to have very high data rate capabilities and stuff, but at some point you always run up to the limits of your storage infrastructure or network infrastructure, at which point you have to decide, okay, I'm going to be collecting only these statistics, only every 10 seconds, and I'll make do. But again, sometimes that's just not enough. And in order to do even a lot of data, some of these systems have to have enormous infrastructures in terms of having very large clusters of distributed databases to store all these time series, and it's just heavy infrastructure. So what I call ad hoc monitoring, meaning what can you do if you know you have an unusual monitoring need that the basic system does not provide for you already? What can you do that's a little personal, that satisfy your need just this moment? And some systems are good at satisfying personal needs, and some are not. This one is one that is really good at personal, small-scale, exploratory kind of monitoring, where it lets you answer questions that you couldn't forecast ahead of time. So I'll be talking about, 10, 15 minutes about this tool. Anyone familiar with it already? Little? Not you guys. Just. So Performance Copilot is an old tool. I say that just because, even though it's new to many people, it has existed for probably 2 decades in some form already. It used to be a commercial product for SGI and their large their computing clusters. It was open sourced probably like a decade and a bit ago, and but it has gotten some mind share, partly because of its commercial history. Partly because, as a part of its commercial history, it had to be made very robust and fully documented, and at higher standards than just a little open source project in some ways. Its main claim, as compared to a more integrated single-purpose monitoring system, is that it's a toolkit, in that it is designed to permit you to define exactly what you monitor as an end user, as a developer. You're not limited to what a system administrator wishes to monitor for you. You're fully encouraged to use the same system for personal needs that you have that particular moment. And the way it does this is an interesting architecture which decouples collection and storage and analysis into distinct but very simple processes, and a very simple processing model, so that momentary ad hoc monitoring needs don't conflict with others. Okay. So one aspect of it that makes it interesting is that there's no hard-coded, no central configured overall system there. It contains several independent pieces. The key part, the basic part, is this single daemon called a collector, and all it does is it fetches on demand current live statistics that a particular performance monitoring user would like. And it's a very efficient little daemon. It's written all in C. It's quite efficient. It doesn't require a Java virtual machine or anything like that. And it's able to serve any of thousands and thousands and thousands of metrics, including per process minutiae, up to system level statistics and many, many other things. It's an extensible widget. It can pull out statistics from database servers, normal Unix daemons that have any sort of statistics exporting engine like the name servers do. Almost everything that has a little statistics exporting function this guy can generally import and then make it available. But key is that it does not do anything with the data. It is merely a server. It does not store the data. It does not poll it. It just holds it ready for when a client comes in to call. So this means that it can make available, again, thousands and thousands of potential metrics that are useful without taking up all the time in gathering it if there's no one listening. Then a whole separate module called the logger exists, and its job is to talk to the collector from the previous slide. It can talk to it locally on a machine, or it can talk across a network, so it can remotely log as a native capability. And all its job is to send periodic query packets to the collector saying, give me these 100, 200, or 10,000 statistics that are current, and then saves those to disk pretty much unmodified. So it's a very efficient way of sending the network packets straight to disk with very little processing involved. It's really a small, lightweight tool that creates files from the recorded history of these metrics. And it's a highly configurable widget, even reconfigurable at runtime, so that each of these logger processes can change what kind of metrics it collects and how frequently. And it's, unlike in other systems, it is not a central system service kind of tool. This is a tool that an individual developer user can, if they wish, start completely for themselves. It's an unprivileged process that just writes files full of metrics. So developer doesn't have to talk to a sysadmin to please log more for him for next 2 minutes. The person can just start this totally by themselves, directed at whatever nodes are running their applications, and it will do the job without a special coordination with anyone else. So that's pretty special. Many of the other systems require sysadmin reconfiguration or stopping of some central service, or setting up more databases to do anything extra. A lot of headache, depending on the system, of course. Here, it can be totally personal. And because it's such a small, special, such a single-purpose tool, it's very modular, very Unixy flavored. So if you want to monitor 10 machines, you run 10 copies of it, and each is very small, so that's okay. But it's very straightforward to just launch either directly or under a sort of intermediary tool like what we call PM Manager, which will then monitor machines that you designate and just will launch these little loggers for you and then bring your data back. But it can be totally personal. Now, how does one actually use all this data? Performance Copilot comes with dozens of tools, generally little programs, but some larger ones too. And each of them is capable of either talking to a live collector, so consuming live data either from the local machine or any of the machines on a network, or can read the archive files that are just being generated by a logger. So each client tool that shows you system stats can talk either to history, or it can talk to present data, either a local or a remote machine. It's all just selected by command line options, and it's a built-in capability to all of these tools. So for example, I'll show just a little bit of examples next, but it is kind of interesting that whereas you're used to running the top command or IOStat, all these guys, they're monitoring tools of sorts, right? You're used to having to log into a machine and then run IOStat there, and then you stare at the results for a few minutes. Well, with this one, the same data that IOStat would print out for local machine, this will give it to you for any remote machine you have access to, as well as any historical data you have from any of those machines, and with just a few different command line options. And so, for example, PM stat is just a little give VMstat impersonator, but it uses the PCP infrastructure to make remote connections. So here you see us looking at 3 separate hosts concurrently in parallel. So those are the 3 hosts named there, and this will, in this case, just scan some pre-selected set of stats from those 3 machines and intermingle them on the text console for you. So it tries to be very simple, reasonably intuitive, but it hides a bit of magic in that we're actually talking to different machines, collating the data, converting all the units, and making sure that even if one of the machines is a Windows box, we still convert its statistics to a same homogeneous kind of dimensionality. So everything will be in kilobytes instead of megabytes, this kind of thing. It's all handled by the infrastructure automatically. To do that unit conversion stuff, the system has to keep track of metadata for every measurement, so it knows a piece of documentation text about everything that it has, and it knows the data types. It knows, again, units, which is it's a little bit different from data types. So you can have a fully dimensioned numbers, so you don't get confused if the kernel version changes and starts printing something as kilobytes instead of megabytes. The system does not get confused. It still knows what the numbers represent exactly so that clients can convert without any confusion. So it's a little subtle issue, but it means that every single chart that any of the tools shows is fully dimensioned. It's a meaningful scientific data. It's not just a curve with a number that's 0 to 100. You never have to ask 0 to 100 what. It's always 0 to 100 kilobytes per second. Okay, it's something that this tool takes very seriously, whether others do not. And the bottom there is just a little demonstration that that this tool is very happy to deal with textual sort of measurements too, not just numeric ones. So one of the agents that comes with PCP is simply listens to systemd journal entries, and we have others that listen to log files, and it can transcribe log records into the data stream, into the metric stream. It's just like it would transcribe numeric results. So it can function as a combined source of numbers as well as text and binary data too, if one really wants to go that far. It does have a GUI or 2 or 3, depending on how you count. So once you collect the data, you can use countless, dozens of these little command line tools or libraries to process them. But also there exist GUIs that we ship. There's a Qt-based one, which I think there's a screen dump in the next slide. There are various web-based user interfaces which run as normal JavaScript web applications. And again, all these run with almost zero infrastructure. These are very, very lightweight, personal level servers. You don't need to install Golang and a big auxiliary database or anything like this. Everything is just very small footprint, very easy to install, personal. It can be personal. Very little infrastructure. So, yeah, that's just what the VM chart looks like. I don't have a screenshot of the web interface, but that's not hard to find. And as I may say, it's you're very invited to try it out, of course. It's available on Fedora and many other distros. The view on the right is just PCP's version of, I think, the ATOP program, ATOP or HTOP, ATOP, which uses the normal local, remote, live, or historical capabilities to represent, to draw the exact same kind of stats that normally a live local tool does. So it generalizes across time and space, so to speak, and still looks familiar, still looks comfortable. So, and one final higher level tool, the PCP inference engine, as it's called, it also is flexible in terms of whether it's a local, remote, or live or historical data analysis tool, but it's a little tool that just takes mathematical expressions based on metrics. So for example, if the load average is more than 5 for the last 10 minutes, then do something. So those kinds of conditions are easy to express. And it too, it is not a core part of the system. It is just, again, an ordinary, potentially personal client that you can run just for your processes or just for your machines, just for your containers, that will monitor only them and will do only what you need at that time. So again, like near zero infrastructure. Then we have tools to take other systems data in or send data out. It's a very much open system in the sense that the data formats are all documented, the APIs are all documented, data flows in and out are well prototyped already. So it's not difficult to send data to and from in its kind of original form. So we take it seriously that we are not a data silo. It's not like data comes into our system and never leaves again. We encourage the data to go two ways. We don't want to own. We don't want to be the central gatekeeper of your monitoring data. I just want to mention this one. While many of these are lower level, this one is a little smarter. It's a new tool that we're building just now, and it demonstrates just how one can assemble the individual parts that I've already mentioned into a more high-level, more intelligent system. That it turns out that a fairly small JavaScript web app can use and integrate the pre-existing pieces to provide something that is fairly unusual, which is a guided educational sort of tool. Not quite I wouldn't call it intelligent, but it's a tool that well, I don't have a screenshot, sorry, but it's not hard to imagine. So picture timelines of only a few metrics at a time, an explanatory text as to what a problem might be as suspected by the system, and what its possible cures might be. And the system does all this by its own monitoring of only selected measurements at a time. So for example, there might be a single screen that measures disk latencies. And if it detects it's above a certain threshold, it'll print out an explanatory text that, okay, your disks are getting saturated. These are various possible cures to it. You can look here to analyze whether the saturation is due to errors or whether it's just overload from too many processes. And it kind of guides down through a tree of possible explanations. And it does this guidance automatically based on its own analysis of the metrics. And then it's all very lightweight, very small, again, personal sized tool. Okay. So that's pretty much all I have about Performance Copilot. So far, it's I hope it helps motivate so far the ad hoc aspect of what I'm really interested in about the monitoring problem space. But it only addresses that part of the system where the instrumentation already exists somewhere in the system. So it'll help if the kernel exports those statistics or programs export statistics, but it doesn't help in the cases where the stats don't exist in a naive form already. So the next tool I'm going to talk about is another tool that our group works on, of course. And this is a tool which, in this context, can be used to fabricate statistics, pull out statistics where they were not already present. So we can dig into the middle of software and pull out its numbers that it wasn't going to give us, but we're going to pull out it anyway. So we need this kind of thing because sometimes, well, often these days, our software stacks have many, many layers. We have libraries upon library and virtual machines and kernels and sometimes multiple of these things. And if something goes wrong with the overall system, it is really difficult to narrow down to which layer might be responsible. So sometimes you have to dig in into internals of these layers, even if those layers weren't instrumented properly in the first place. So sometimes you have to investigate what's going on inside them. So our general approach is to look at this problem as a debugging problem, as if what we want to do really is imagine sending a debugger to into these various layers, any of the layers, because we don't know where the problem might be, and let the debugger snoop around and collect statistics for us, or investigation, and then once this investigation is done, then those responses, the resulting numbers, can then go back into the monitoring system and then flow back up to the user the same way as normal statistics would. So that our tool of choice for this task is to investigating the internals of mystery layers of software is a tool called Systemtap. Anyone familiar with it? Heard of it? A little bit? Okay. So some of these will look familiar because the mentality between here and PCP, there's some common elements. Again, it's a toolkit rather than a single integrated widget. It's a tool building tool. While it comes with a lot of prepackaged samples, prepackaged information, it is really there to let an educated person use it to perform new kinds of research, new kinds of investigation. It deals with live data as opposed to historical data, so that's one place where the PCP slide and this one is different. But in some other ways, the mentality is very similar. It's a personal tool. It's meant to satisfy your personal needs at that time. And it's not something that a system administrator needs to do for you. It's something that you do for yourself. So you can think of it as a programmable debugger, except like GDB, except much faster, and it's able to run in many, many different layers of the software stack up to and including the kernel. So that is an unusual combination to have such a wide scope. It's a programming system, so there's a programming language involved. So it's more higher level of commitment is needed to use it, but it gives one a tremendous amount of power to investigate things. And we found that tools that don't provide this much level of control just can't answer some kinds of questions that really do happen. So we found we really did need this level of expressibility. So if you know that you might need to look into running software, how would you start? Well, first is see if someone else has had the same problem before. So our first advice to users is to just look at our library of samples. It's up on the web and it comes as a part of the software distribution, and it's a whole gamut of a couple of hundred examples. Some replicate very common jobs, some replicate silly stuff. There are games, there are sysadmin spying tools that the sysadmin, a privileged user, might use in order to monitor other users. There's a wide variety of things. So about half the time when we get asked for help, half the time we can point people to one of the examples that already exists, and that's good enough. If, on the other hand, there isn't such an example, then the next step is to write one of these Systemtap programs for oneself. So it's not going to be very long. Just going to give a quick overview of what that feels like, what that looks like, just to give a sense of the power. So the first element is to identify points where we want to extract information. And these points can be anything from parts of a source code of any software that you have access to there. It can be any sort of event source in a kernel that exists there. It can be interfaces to auxiliary user space programs so that a Systemtap program can talk interactively to a user or to another program. So anything that can be phrased as a form of something happening, perhaps with parameters, like a function that got called and it has parameters, or a statement got executed, or a performance counter overflowed because we had too many cache misses. Any of those kinds of things can generally be represented as a Systemtap probe point. And it has a little naming syntax to identify them. And a single Systemtap script will have one or more, generally many more of these probes, because generally we're interested in multiple events and coordinating between them. So once we named what we do, once we named the places where we might want to gather data from, the next step is to decide what to do with the data. So we have many choices. It's a full programming language. It looks a bit like C, so you see it has printfs. All these dollar variables are for accessing context from the event source. So if we set a breakpoint inside a function, then the dollar variables will be whatever actual variables are available at that time in the target source code. So it lets us access, just like GDB lets you print a variable from a program you stopped in. This is exactly the same thing, except we can also pretty print and we can manipulate things. We can express general logic, we can traverse data structures, we can process strings, which is important in sometimes. Some other systems deal with numbers and then let you have one kind of condition but nothing else. We let one express fairly complicated predicates like, has this process done a system call in the last 5 seconds? Those kinds of expressions are expressible here, whereas other systems will not let you do that. We have some built-in statistics features too, so again, it makes some things very straightforward. We can also do things like impose, we can actually make changes to a running program. Sometimes that's necessary if there are security bugs, or sometimes you want to trigger inject default, so you want to trigger some unusual response. You want to simulate an out-of-memory indication, for example. So we have ways of letting the Systemtap user modify state. It's not just for debugging, but for bug fixing purposes too. This sometimes comes in handy. Obviously, there are different levels of privilege for different levels of destructiveness. For those who care about the implementation aspects, it's a full. The Systemtap language is a programming language, so it has to be parsed. It has to be executed. Our execution model traditionally is the next kernel module based model. So it means we actually create a kernel module on the fly that does the same job as the script requires. But we also have 2 other backends that are not Linux kernel module based that are similar in capability. So there's a pure user space one that's based on the Dynins library. Anyone's heard of this? Know what Dynins is? It's a C++ library that lets one inject code into running processes. It's like a binary rewriting profiling instrumentation library that comes out of a university. So anyway, we can use that same library to inject Systemtap instrumentation into running programs. It's a completely unprivileged user space sort of thing. We also have been in touch and monitoring the progress of the Linux BPF virtual machine. Have you guys heard of that? So we've been keeping close track of how they're progressing, and we have a prototype whereby Systemtap uses the virtual machine that is, I think it's kernel 4.5 and up, which lets some simple type of programs be executed under a different protected environment without all the kernel module safety worries. So we're constantly investigating more and more different execution backends for the same scripting language, for the same scripting environment, but to adapt to different people's needs. So it's a very broad capability tool. The reason it came up from the ad hoc monitoring, though, is because once you can look inside how a piece of software works, you can find out the numbers that it wasn't telling you. You can find out how many web requests go around a loop, how frequently it goes through, how full are its internal caches, right? It might not tell you anything about its own internal caching statistics, but with this kind of thing, if you can actually look at their data structures, you can pull out those numbers, even if there was no other way of pulling it out. You can pull out those numbers and expose them to Performance Copilot, and then it can be injected into the rest of the monitoring system. Okay, so pretty much ready with that. I'm happy to answer questions even now if you guys have anything. Shoot.
So if I have an app or application that I want to instrument to expose some internal state or whatever, should I be looking at is there an API to expose that data to PCP or Systemtap or some generic instrumentation framework that could make it available to anything?
Right. The question was how a person who wants to instrument their program could do so to get it to PCP or to Systemtap. And the answer is yes to both questions in different ways. So PCP has a library, actually several possible libraries, which you can link to your program and to export values in a very low overhead way via shared memory. And then any numbers that you put in there will get automatically visible to any PCP clients downstream. If you want to identify Systemtap level points, then yes, there's another way of doing that, which is the exact same method that the dtrace system has, which is that you put some macro calls into your program via a header file we provide, and it identifies potential breakpoint locations and data that goes along with them. And then this becomes a very high performance, very portable way of denoting where you think interesting points are in your program, which makes them very discoverable to other people. And many serious programs already have this exact same kind of instrumentation attached to them. Apache web browser, databases, shells, it's all over the place already. So chances are if you run a Systemtap list command to find these, you'll find hundreds of them on a Fedora or RHEL distro already, and you're welcome to add those in, and they're basically zero overhead. Literally, like a no op is all that exists in the object code, so it's very efficient. So there's still lots of work in progress. We're still fairly new to the broad cloud world, so we're still finding limitations as to how easily one can deploy these tools to a large cloud. So we're still working on scaling, making sure it's easy to run, but we know it's important, and we're on it. And we also are building support for more and more scripting languages. Our Python and Java support in both sets of tools is getting better and better. But I think those are the biggies. I think Golang is also coming in many respects. But we know more needs to be done. And okay. When I say solves, it's not completely solves, not 100% solves, but it addresses a larger fraction of the problems that a pure naive monitoring system would have. So with PCP, we get very good ad hoc capabilities, assuming that there is enough data potentially available. And if you add Systemtap to the mix, then you can make an order of magnitude more data potentially available, which is the data that comes in from practically black box binary blobs. You can kind of crank them open and see what's inside, and that data too can be then put into your ad hoc monitoring needs. So I think these two systems have, to some extent, a bit of a synergy, and using them both together can let one dig into problems that alone you can't, and you can get nowhere near with just a plain old standard charty kind of monitoring system. And just some links. And that's all I have. I think we might have time for one or two more questions, maybe. Anyone else? Shoot.
So, how exactly do you, from Systemtap, do you export metrics to PCP? I don't know if you saw that in the slide.
Yes, I just I left a little tantalizing hint. There's a YouTube video that actually demonstrates that. The way that works is that the Systemtap script exports a procfs file, and PCP knows that it can look for procfs files of a certain syntax in a certain place, and therefore it can pull Systemtap generated live statistics from a synthetic procfs location, and it will then transport them into the normal PCP data stream. So that's one way. There are others, but that's the easiest. And there's a little YouTube video, something like 3 or 4 minutes long, that shows the whole thing working, and it shows profiles and numbers and all kinds of stuff that this can be used for. That's it. All right. Well, thank you very much for making time and sitting through. And if you folks have questions after, of course, I'll be around. Yep, thank you.
Alex.
Hi.
Do you have a live demo?
Short one, but yes.
So do you need internet access? Because that should work better than Wi-Fi. Let's try it.
Well, I would not need wireless.
Oh, okay, that's fine.
Everything is on my machine for safety reasons.
Yeah. Just in case.
Yeah, who knows what will happen. So what's the resolution of the... What's the resolution?
I'm not sure. Probably 1024 the standard. We'll see.
Oh, it's...
If you want to hire, you can try to HDMI, but
It should be fine. Oh, it's big enough.
oh, okay.
Okay.
For example, it's especially good when the system uses a source file.
I think they already told you, or maybe you heard of it. This microphone is just for recording.
Okay.
So in case of any question, please repeat it for the recording also.
I get that.
And what?
I get that fully, so
Okay.
fine. Then we will be seeable.
So you have plenty of time.
And I should be done in 50 minutes, right? Like 40 and give like more than 5 minutes for Q&A.
It's up to you. The 50 minutes is the kind of the recommendation, but in the case of many questions, we can go a little bit longer.
Okay. We'll see. I don't know whether there will be any. But
You should hope for many questions.
I do.
And if you have water here, because that's already.
I'll need it. Yeah, thanks.
We will show you the time what's left. So
Okay, when do you start showing it? Like 20 minutes before the intro?
like 10 minutes before.
10 minutes before.
Then 5 minutes and then
Okay.
1 minute, and there is a last question table. You'll see.
Okay.
Thank you.
By the way, yesterday was a presentation about the Visual Studio.
VS Code, yeah.
Were you there?
Yes.
Did you like it?
Oh. Well, I don't like the way it looks. I like some of the technology in it.
Yeah.
So
It's separation between the presentation layer and the language stuff.
yeah, that extracting all the language-specific stuff from the IDE is pretty good.
But he mentioned that about something Eclipse CAG or something like that. To work.
Yeah, that's so.
I didn't get the idea from the presentation. So.
Eclipse Che.
Chi, or is it Chi, or you pronounce something like this?
Oh, I don't think. Okay, so the
You can use this connection.
Actually-
on the right side.
I never used it on the laptop.
Yeah, just for this, yeah. I came in on Wednesday, and I'm meeting tomorrow morning.
That's good. You must have given a talk.
Yes, no, on Friday.
So what Che is really a web front end and web IDE. It shares almost nothing with Eclipse itself, the desktop Eclipse.
So it is really web frontend?
Yeah, it's,
okay.
that's the way it works. What it does is you have the runtime, the Che as a Docker instance, and all your workspaces are another instances, another containers,
Actually, it was fast.
and your language-specific stuff is yet another container, and they orchestrate them together so you can mix and match.
Interesting.
There are a number of limitations. I mean, it works well for let's say bytecode and interpreted languages. It's not easy to make it work that way for, let's say, C.
Yeah. So more likely to web developers to HTML, JavaScript, and
Yeah, I think that's the target.
yeah.
Mainly targeting probably Java, PHP, that kind of work.
Nice.
Dobra, dzięki za to.
Вчера стигнали ти време?
Имах време, прибрах се и скъпах се, легнах си.
Не си цъкал нещо.
Не.
Добре, това се чувстваш.